In this video, we are going to take a look at dilution of a solution. This just means how we move from a very concentrated solution to a less concentrated or diluted solution. And it's useful in chemistry and like in a practical lab because more often than not, we are given a stock solution which is very, very concentrated, and we're not ever really going to use the most concentrated version because it's not economical. So we'll have to dilute it to a more safe and reasonable concentration with which to work with. So extending from the previous video on concentration, we have our box with 5 particles in it. So 1, 2, 3, 4, 5. So this is our box 1. And within that box, I have 5 particles. We'll talk about moles in a second, but just 5 particles. So if I then take this box and I blow it up, not blow it up, but I expand it out, so I make it bigger. And so I've increased the volume within the box. So as a result, this box with the 5 particles has become less concentrated or dilute. But the key idea here is that between box 1 and box 2, I have the exact same number of particles. So the number of particles hasn't changed. It has stayed the same. So I have 5 particles in my first box and I have 5 particles in my second box. So they are the same. So that's a quantity that's the same. So if I extend this further, and let's take, now I have a beaker, and inside that beaker I have 1 liter of water. And within that 1 liter of water, I have, let's say, 1, 2, 3 moles of some chemical, the red chemical in this case. And if I then add more water to it, and I fill up that beaker a bit more, in this case now I have 2 liters of water, but I still have the same 3 moles of my chemical, my red chemical. So between the 2 cases, I have the same number of moles. So the number of moles for beaker 1, well, it's equal to the number of moles for beaker 2. And if we remember last time, the number of moles is equal to concentration times volume. So I can just substitute this in. So the number of moles in my first beaker is equal to the concentration, or original concentration 1, times the original volume 1. Then over here, the concentration, or the new concentration 2, times the volume 2 should be equal to the same number of moles. And so now I have this relationship between the before and after I dilute. And this is called the C1V1 C2V2 equation. It is actually one of the most practical equations I've ever come across in chemistry. When you work in a lab, you will do this equation a lot because you will always have to dilute or find out exactly how many moles that you need to dilute to using this equation. And it's super, super handy. As long as we know the original concentration and the new concentration or the new volume, as long as we know 3 out of these 4, we can solve for one of the others. So if I say if I have a concentration of 15 molar and I want a new concentration of 1 molar, but I only want 200 milliliters at solution, I could find out how much I have to add in originally and then dilute to the new concentration or pour in more water. So let's take a look at an example. I want to calculate the new concentration, molarity, moles per liter. If enough water is added to 100 milliliters of a 0.25 molar, in this case, molar is a unit, not molar mass, of sodium chloride to make up 1.5 liters. So I'm going to write down, as always, my knowns and unknowns. So I have my original concentration here as C1, and it's equal to 0.25 moles per liter. My original volume is 100 milliliters. But because it's milliliters, I have to convert it to liters. Just divide by 1,000, and I get 0.10 liters. I want to know my new concentration, my new C2, so I don't know that yet, so I'm just going to put a question mark. My V2, my new volume, is told to me, and it's 1.5 liters. So I'm just going to use my C1 V1 equals C2 V2 formula. I'm going to rearrange and I'm going to solve or isolate C2. So in this case, C1 V1 over V2 is equal to C2. And I'm just going to plug in my numbers. So C1, 0.25 moles per liter. V1, 0.10 liters. V2, 1.5 liters. That gives me my C2 value. Move this down. So I'm going to plug it into my trusty calculator. So I get 0.25 times 0.1 divided by 1.5. And that's going to give me a brand new concentration of 0.0, another 0.017. Well, it's 6 repeated, so it's 17, and that's equal to my new concentration. So I started off with 0.25 molar, and as I added in more water, the concentration's now changed to 0.017, in this case, moles per liter. So this is a very, very handy tool for us to use. It's not very difficult calculation to do. Just make sure we write down everything we need to know and everything we know and everything we need to know, and just plug it into our calculator, and it gives us a really nice and neat answer. But the key idea is to understand that as we add water or we add solvent or volume, our concentration will go down. It becomes more dilute. Or we can use it the other way to find out how much of a stock solution we need, or how much of that stock solution we need. So at the end, concentration always is particles per volume, and in this case, if we dilute something, number of particles doesn't change, only the volume.